All right, welcome. Right now we are going into our retaining wall, okay? Our cantilever retaining wall. You can see the height here, 5,500. I can change. You can see the casting height and then the wall height. You can see it's always coming as the same, because this is the height of your cast when you cast the, since it's a reinforced concrete, you cast your concrete in it, okay? So 5,500 plus is actually the same with the wall height, okay? So we have the wall length. Now, like I said, you can see it's actually giving you the name of all of this. Wall height, which is H, from here now to this place is your height, which is 5,500. The casting height is also from here now to the top here, which is also 5,500. The wall length, okay, is actually 6,000. Okay. Let's say I change this wall length to 4 meters. Now you can see stability analysis are successful. Whatever you click here now, whatever information you are imputing here will affect this preview that we have here. So you are going to see it's like giving you a picture of how it's going to look like in real life, okay, or a picture of what you are trying to, of the information you are actually imputing right now, okay? So the eccentricity at 200, which is E, you can see the informations here are here. We have A, we have B, we have E, we have H, we have T1, we have B1, okay? All right. So your A is 300, the eccentricity 200. My B1 here is actually 550. You can as well increase it, okay? So just like your design, when you are designing, it may fail and it may actually pass, okay? So you are supposed to provide whatever you actually want the software to actually use and analyze and design for you based on the nature of the site or the condition of that particular site. That will determine whatever you are providing here right now. Okay, so the base plate front 550, this one 500. So you can play around with the informations until you get one that actually that will tell you the stability is actually once you are getting a green like this, you can see everything here is giving you green. It's telling you that this wall has actually passed. Okay, but you can see aside from the geometry, these informations we are imputing is just for the geometry, okay, like the cross section of this particular retaining wall. Okay, now we are supposed to provide the soil parameter, okay, based on the nature of that particular site. Now, this information is from the soil tests that must have been carried out on the site. Okay, so whatever informations that you have on that site are the informations you are actually going to type in here. So the fill parameters, these are the material you are actually going to be using to fill, okay, this wall. Okay, so the soil parameter, like I said, is the natural condition of that site. The nature of that site, they must have taken run tests on the soil that is actually there, knowing the capacity and all of that. Those informations are the informations you are actually going to provide here. You can see, if you want, you can see this is ground soil. This is backfill, okay? If the filling should be at the back and you're having probably a front fill or a back fill, whatever that is the condition there and you want to actually provide for. So on drain internal friction, like I said, all of these parameters are gotten from your soil reports. So whatever you have gotten from your soil reports are the informations you are actually going to type in here. All right. The field parameters, you can see soil field height at the front here, 1,000, at the back here, 5,000, okay, the height of water table. All of this information are also gotten from the site, okay? So the height of water table here, you can see at the back is, at the front is 0, and at the back is actually 1 meter, okay? A soil slope angle, magnitude of distributed surcharge, distance of distributed surcharge, length of distributed surcharge, okay? So all of these informations, you must definitely get them from the condition of that site, okay? So the moment you have all of those, your informations, let's come back. The moment you have all of those informations for your field, you come down to your analysis. Now, this analysis here, you can see stem effects. You can include the effect of stem from front face slope on the soil, pressure, all of this, whatever information you want to actually include in your analysis. Okay, so you can add all of that to your analysis and then you analyze that particular wall. Okay. So design parameter here, you can see this is the concrete grade, 60/20. So let's say I switch this grade of concrete to 20/25. Okay, I always like to use this grade. So you can specify the characteristic strength of the concrete, the characteristic strength of the reinforcement. Okay, so we can see here is 410. So you can change that to suit whatever strength of steel you want to actually make use of. And then all these informations are actually correct based on your characteristic strength of your steel of 410. Okay, so if you want to cross-check, you can cross-check, you discover it's actually the same, except you want to make some little alteration to whatever that is there. So which I am definitely not going to do that right now. So you can change the grade of your link, or you can leave it to the other one that is there. So and then, you know, the strength of your steel, the characteristic strength of your concrete is gotten from the lab. You have to run a test on your concrete in order for your concrete to meet up to that strength. Okay, where you take your concrete cube to the lab, in your concrete lab, and then you run tests on them, and then in your casting on site, you must make sure that your concrete grade is up to that standard. Okay, that is another story, a story for another day. The reinforcement for your link is also the same way, where you take your reinforcement to the lab and then they check the tensile strength of that steel. Okay, analysis summary. This is the entire summary for the analysis. You can see for your loadings, okay, direction, this is lateral direction. So let's go to total failure. Then you come to your design. So you can see it has loaded our design. Now you can see, based on the information I provided, this design has actually passed. Okay, but you can see here now that my reinforcement here is telling me 37Y13. 37Y13. Okay, so you may want to change the sizes of this reinforcement. Okay, You may want to change the size of this reinforcement in order for it to give you, so you can specify the thickness of your reinforcement based on what you want the software to actually make use of. Okay. All right. So you can even see here Y6. Getting Y6 on in the market is very difficult. I don't think you can actually, well, except you make a special order for that. Getting Y6 in the market can be very difficult. So you specify the sizes of the reinforcement that you want the software to actually make use of for you. Okay. Let's come back to rebar here, and I come to diameter here. Now, I'll click on select all, and I'll click on unselect all of them. So here you can select the sizes of reinforcement that you want this software to actually make use of for you. So I'm going to specify Y12 and Y16. And then for my links diameter, I'm going to specify Y10, and I'll click on OK. Okay, so you just go back and then you redesign. So you can see everything has actually passed. This time around, it has not used, okay, you can see it's no longer that Y13 we were having the other time. Now it's Y16. So you can play around with it and change to whatever size of reinforcement you want the software to actually provide for you. So you can see here where we're having Y6, it's now giving us Y10 as the reinforcement here. Okay, so you come to your stem here, you can see what you have. We have 37 Y12 at 120 spacing. Okay, here I have 26 Y12 at 200 spacing, 26 Y12, 200 spacing. Okay, base plate, 15 Y12, 200 spacing. So you can confirm all of this here. And then once you click on drawing and reports, okay. So here now I can generate my reports where you can see everything on here has been checked. So all of these are going to be included in our reports. So let's say I don't want my display quantity table to be included. All I need to do is just to uncheck them, okay? So whatever I don't want this software to include for me in my report, I can just uncheck them. So, but let me keep them checked, and then I'll click on generate report. So once I click on generate report, you can see it's actually generating the reports right now. So you can see my retaining wall 1. So these are my reports. So you can see retaining wall dimensions, soil parameters. These are the soil parameter, front fill, ground fill, the analysis, the factors of safety. You can see overturning stability ratio, sliding stability ratio, factor of total failure, surcharge load, code parameters. Okay. So the report is going to be much because everything here is actually included based on what I have. I have checked on everything. Okay. So you see your quantity measurements, your concrete quantity, formwork quantity. All right, you can see it's included. Reinforced concrete design. Okay, unit weight 24, yeah. Rebar grade 410, concrete grade 20/25. Okay. All right. So the same thing here. Similarly, you can just click on PDF, or you can save it as an Office file in order for you to you can make some little changes to whatever that, to the reports that is being generated by the software. So I'm just going to leave it as it is, and I'll close this. So that is my report. The next thing here, you can see types. You can switch to whatever kind of tie you actually want the software to represent for you in your detailed drawing, and it's going to give you that just as you have specified. Okay, I'll click on prepare drawing, and I'll click on yes. In order to prepare detailed drawing, you must drawing design must be renewed. Do you want to renew the design? Renew the design, yes, and I'll click on yes. So I will just find somewhere around in my window and I will drop that. So you can see it has provided this, you can see the whip hole here, 100 diameter, whip hole, both direction, 1,500 millimeter centered center. Crush tone here at this level. Here you have a drainage pipe, okay, permeable fill, okay, 500 here. So all of this is based on the information I have provided at my geometry and the information I have given to the software based on the condition of the soil and then the fill material that is going to be used to fill in the retaining wall, okay? So based on those information, and that is what the software we use to analyze this particular structural member and then design the structural member and then give me a detailed drawing based on the reinforcement I have specified, the size of the reinforcement, the grade of the concrete, and the characteristic strength of the steel, okay? So you can see this is more like a, when you cut a section, the front and back here, you have in 26 wide, 12 at 200 spacing. So the front and back has the same size of reinforcement, the same shape of reinforcement, the same length of reinforcement. So that is why it's giving you the same bar mark. I have explained that in the previous one. Okay. So here you have the retaining, the quantity takeoff, okay, for this particular retaining wall, okay? All right.